دكتورة هدى،
Yes.
الكيمياء التحليلية مو الكيمياء الكهربائية والطاقة المتجددة من جامعة
نعم.
المملكة المتحدة مو؟
بلي.
هاي مالتك.
نعم.
تمام. لا. هلا مرحبا دكتورة. هسه الصوت اوكي. هسه دكتورة إيه
تمام.
جربي بس نسوي تيست.
تمام.
تفضلي دكتورة.
اوكي، واضح يمكم؟
واضح.
تمام. تمام. الو. السلام عليكم. عليكم السلام.
ولا که هی باز داو که معمول از پرکی بچم از اینکه که هم دو دقیقه کدیده موبایل دب کامپیوتر داخل
كانت السكرين شكبت بس تجربة قربان.
بلا باز داو که معمول دكتور.
تمام. تاودينينا انت.
شتش.
تمام دكتور. اگر تابا كابت انتو تيست كي تو شيء سكرين كي بركي بري خوب دي اگر تشكبت عرس كي.
بلا. كده صح كمان دكتور.
داتا شوك تشتك سلايدك.
بخوده فيرا تشتاقنا باز داو که معمول دو دقیقه کدی. از كده انا ازدحام كده.
هيك مش بينك.
ما قلت يا اسيس.
تمام قربان.
ما قلت يا اسيسيه ما بيجي. اشتازت.
لا راح تاخذ القرا ايش ما دو سي دقيقة كت ماينس بيجي بس بيمكن بس دكتورة منار جيبهتن.
اسيسيه ما منا دكتور.
راح تاخذ القرا. يك دقيقة. ما تشاهد في الدكتور ما درستها.
لا قصد من بو برزنتيشن من السي ام لا
بس نبدأ فيه. أولي دكتورة منار دكتورة دينا بشتهنجي آيات شازلي تشاري.
ايه بقى لا يبغى عندك هذه معمول من يا حاضر كذي بس
وقت هي
درست دكتور
يلا باش
زور سباس بده
Good afternoon. I'm talking to you from Cairo. This is Professor Manar Abdulraouf, Professor of Polymer Science at the Egyptian Petroleum Research Institute. Do you hear me?
Yes.
Okay.
Hello.
Start my presentation.
Yes, we hear you.
Myself, okay, then I'll start my presentation. My research interests focus on utilization of green polymers to replace petroleum-based materials in different applications. I have published many research articles in environmental topics, and I concentrate my work on green polymers and green material. Through this, I was the PI of an international collaborative project between Egyptian Petroleum Research Institute and Lehigh University. This project was entitled Green Chemistry Approach for Preparation of Hydrogels for Agriculture in Desert Conditions. We could get from this project an advanced atomic force microscope. Through my work on this microscopy, I realized that it is very important in material science. Therefore, I decided that this seminar or this lecture will be about the AFM in material science. Okay. Can you see my screen? Can you see my screen?
Yes, yes, we can see.
Okay.
Yes, we can.
The objectives of this seminar: how does AFM work? Most common modes of AFM, general applications, what are the limitations of AFM, and advantages and disadvantages of AFM, and the future of AFM. Simply, AFM is based on two main things: the laser and the cantilever. You can see that the cantilever is a small probe with tiny tip. On this probe, the laser beam falls, then it is reflected on a detector. The reflected laser beam is tracked by a position-sensitive photodetector that picks up the vertical and lateral motion of this probe. The detector sensitivity is calibrated in order to convert volts measured on the photodetector to nanometer of motions, okay? Different modes of operation for the AFM according to the tip that is placed inside the cantilever holder to detect certain properties in the material. Static force mode, I can measure surface topography or I can scan surface topography. Dynamic force mode, surface topography and roughness parameters. Force modulation mode is used to determine material contrast and difference in stiffness between the tip and the sample. Therefore, it can be used for determining the mechanical properties of the material. Lateral force mode, imaging vibration in surface friction. This is another type of mechanical properties. Kelvin probe force mode, contact potential. Therefore, it can be used to measure electric properties of the material. Phase contrast mode for phase variation. For instance, when I add or I mix or I blend two types of polymers, they can be distinguished clearly via the AFM, and their ratios together can be monitored via the AFM, as we will see later. Therefore, the AFM can be used to measure the mechanical or to monitor the mechanical properties such as adhesion, stiffness, friction, dissipation. It can also be used for electric properties such as capacitance, electrostatic forces, work function, electric current, and it can also measure or determine the magnetic properties of the material. All these applications have very importance in material science. For instance, these two images show the difference between smooth surface and rough surface. You can see clearly the topography of the rough surface with respect to the smooth surface, which is non-corroded medium. This is the corroded surface. A lot of bits can be seen clearly via the AFM photo or image. The process of corrosion itself can be monitored clearly. This is clear surface or clean surface or smooth surface, and this surface at the beginning of the corrosion process, and this is a rough surface, very rough surface after the corrosion process is completed. Here are several nice photos for the application or AFM. This photo shows the electrostatic force measurement on aluminum dots deposited in wood. This photo shows topography of multi-layer graphene. We can distinguish the layers of graphene even at very low scale. And this nice photo shows topography of strontium titanium oxide in dynamic mode. The polymer mixtures and the polymer modification reactions can be monitored also via the FM. Here is the polymeric glass, and these two images show the difference between copolymers, where the two components are reacted together in clear way, whereas this is the AFM phase image of polymer blend. We can see that the polymers don't react together, and the two polymers can be distinguished clearly from each other. I want to show you the working area of my AFM. This is the tip, sorry. This is the tip of the cantilever contacting the surface, okay? This is the surface, and the topography of the surface is very clear. It is very pitted surface, and these are the parameters to be adjusted before scanning the sample. Through the AFM, I can measure the roughness of the surface. This table shows the roughness parameters of this the surface area of the sample scanned at 2.5. Decrease or increase the area to be scanned. I can also adjust these parameters in order to obtain the clearest image that can be obtained via the AFM. I put here some photos for my work, which confirm, these photos confirm the utilization of AFM in monitoring the chemical reactions. This is the neat guar gum. You can see that the surface of neat guar gum is very smooth, and the roughness is the height is very low. After modification of guar gum into carboxymethyl guar gum, the surface roughness increases and the height of the surface increases. The height is calculated by the difference between the lowest point and the highest point. We can see that there is an obvious modification occurred to the surface via after the chemical reaction. This is a hydrogel. We prepared it in our lab. This the hydrogel, the dry hydrogel, and this is the swollen hydrogel. I will show you the AF images of this hydrogel in order to realize or to confirm the utilization of AFM in monitoring the swelling process of hydrogels. These hydrogels are in different degrees of swelling, in different stages of swelling. This is at the beginning of the swelling, this is after swelling, and this is at the end of the swelling. We can see that the surface is highly modified by the swelling process. These images also show the dry hydrogel, and this is the swollen hydrogel measured by AFM while it is in swelled state. Okay, we can differentiate easily between the swelled and the non-swelled hydrogel. What are the advantages of AFM over other electron microscopes available? There are three main types of electron microscopes which are used to monitor the surface topography or the interior of the sample or the matrix. They are SEM, TEM, and AFM. The SEM is used to monitor surface topography as AFM, but it has more features such as electric, mechanical, magnetic properties, and force modulation. The same sample, the same size of sample used in SIM and AFM, but the samples used in TIM are much greater. The magnification power of are nearly the same, but the TIM, the sample preparation is somewhat difficult in the TIM rather than the AFM and the SIM. Moreover, the AFM can image in all environments, such as air, liquid, and the samples really are easily prepared. I put just the sample under the tip and start monitoring or start scanning. Okay, interaction with surface allows the measurement of physical properties of surface in different modes, as I said earlier. What are the main disadvantages of AFM? Data, all the data are dependent on the tip. When I want to measure mechanical property or electric property or whatever, I have to change the tip. I put certain tip for certain purpose. These tips are very expensive and are very fragile and are difficult to be placed in their position. So this is one of the disadvantages of AFM. Be damaged or the sample is not put in proper way. The future of atomic force microscopy, sharper tips must be improved, because I told you that the tips are very fragile, are very thin, are very sensitive, and atomic or resolution images of leaf cell surfaces must be developed, because cantilevers can injure the living cell. So the technique of AFM itself must be adapted to living cells scanning. Conclusions: AFM is becoming one of the most meaningful techniques of investigation of surface forces at the moment Thank you for your attention. Now, I want to present the next presentation by Dr. Dina Ahmed. Dr. Dina.
Thank you. Thank you.
Before and after each day.
Could you hear me?
Yes, and we can see you.
Yes, hope you are safe and well. First of all, I'd like to present my thanks to the University of Duhok and Women in Science Without Borders and all the organizers for this conference. I hope that the conference will be in attendance in the next year when the pandemic is over. Before starting, I'd like to introduce myself. I'm Dr. Dina Saadi Ahmed. I have got my PhD in polymer chemistry from the University of Tikrit. After that, I worked as a researcher at Al Nahrain University. Then I worked as a lecturer at Medical Instrumentation Engineering Technology at Al Mansour University College. May I introduce my wonderful international team from different universities in the world. The title of my presentation is sphere are increased. The second one, global warming. Dioxide is considered one of the main greenhouse gases which causes global warming. This has such as flooding and drought due to the change in nature equilibrium. Recently, research has been directed to find ways to capture a green method such as reduce number of cars or uses more bicycles or according to the last literature survey, COVID-19 reduces global warming. Recently, many efforts have been made to develop porous organic polymers for their use in gas storage and separation, catalysis, harvesting, molecular sensors, and other interesting applications. Two main strategies are used in the design and production of these materials. The first one involves selection of suitable monomers, and the second involves the choice of a proper synthesis. These polymers storage capacity and physiochemical stability at high pressure. These polymers have remarkable carbon dioxide and also hydrogen. The second one, porous fusidates metal complexes as hydrogen, methane, and carbon dioxide storage media. In this paper, complexes containing complexes depending on the type of metals. The gases uptake for carbon dioxide, hydrogen, and methane was found to be dependent on the type of metal, the surface of complexes, and porous volume and diameter. We can see FESEM image revealed that complexes have heterogeneous and porous structure. In addition, this image shows that the presence of tiny particles agglomerates with a variation in particles' shapes and sizes. The third one, melamine shift bases as highly efficient media for carbon dioxide. In this FESEM image shows that the surface morphologies of the synthesized polymers were similar to coral reef. They had a grooved network, amorphous surface, and a high surface area. Most important, they had considerable carbon dioxide storage capacity at high pressure. The high carbon dioxide uptake capacity of this material were due to their geometries. The other one, carvedilol metal complexes as carbon dioxide storage media. These complexes were synthesized as potential carbon dioxide storage media. These complexes show reasonable capacity toward carbon dioxide uptake. The surfaces of these complexes were amorphous, uniform, contained groove network, and irregular blocks. These properties could help the particle's porosity to enable gas capture. The next one, the Tilmisartan organothin complexes as carbon dioxide capture media. The FESEM image of the synthesized organothin complexes revealed that the complex have a homogeneous and porous structure. In addition, this image shows the presence of tiny particle agglomerates, and organothin complexes have different shape and particle size. These complexes contain a butyl substituent were more efficient as carbon dioxide storage media than the complexes contain a phenyl substituent. The dibutyl complex had the highest BET surface area and the largest volume, pore volume, and the most efficient for carbon dioxide. The other one, organic polymers containing silicon as carbon dioxide. The design and synthesis of new multifunctional organic porous polymers which containing silicon has attracted significant attention over the years due to their favorable properties, which make them suitable for carbon dioxide storage. In this study, the synthesized polymers exhibited microporous structure with high surface area. The last one, novel heteroatoms doped porous organic polymers as efficient media for carbon dioxide storage. Herein, the heteroatoms doped porous organic polymers containing phosphate units. FESEM image showed that the surface morphology of the synthesized polymers were similar to coral reef. Also, they had grooved network, long-range periodic macropores, amorphous surface, and a high surface area. The high carbon dioxide uptake capacity of these materials were due to their geometries. Thank you so much for listening. Be safe.
Thank you, Dr.
Thank
Dina.
you.
Thank you, Dr. Dina, for your fine and interesting talk. Really, I get used of many informations you mentioned, but I have many questions after at the end of this session.
Thank you. Thank you. Okay.
Dr. Ayat? Dr. Ayat attends this session or not here? The next speaker, Dr. Ayat. Dr. Ayat Shazli. Maybe she is not here?
Sorry, Dr. Manar.
Dr. Ayat Shazli.
Sorry, Dr. Manar.
Oh, okay. Welcome, Dr. Ayat.
No, I'm Dr. Huda.
Dr. Huda?
Yeah.
Okay.
Could I present my work instead of Dr. I, because I have to leave after 30 minutes. I have another class.
But your name is not mentioned in this session, Dr. Huda.
No, it is in the last one.
Okay, can you introduce yourself, please?
Yeah, of course. My name, first of all, I would like to thank the president of the conference and the organizing that held this amazing conference for women scientists for the first time in Iraq. My name is Huda Al-Hassan. I completed my PhD in 2018 and from Hull University, which is in UK. And my specialize in electrochemistry and renewable energy. I'm working in Babylon University in the Environmental Research and Study Center. So I'm really interested with the environment and how can we solve the pollution from our earth. This is brief introduce of myself. I think my subject is different from all the topics of this session. So may I share the screen with you?
Okay, please share your screen, and you have 15 minutes to give your lecture, okay?
Okay. Can you see it? Can you see it?
Okay,
now?
okay.
So my presentation entitled Educating Children the Sustainable Development Goal, a story series. It is a series of story with pictures which was written by pharmacist Zainab Al-Musawi and I. The pictures were drawn by Dr. Safa Lutfi, who has many children's books published local and international. So, why SDGs, the 5 PS? The Sustainable Development Goals, which is SDGs, or global goals, are a collection of 17 interlinked global goals designed to be a blueprint to achieve a better and more sustainable future for all. The Sustainable Development Goals were born at the United Nations Conference on Sustainable Development in Rio de Janeiro in 2012. The objective was to produce a set of universal goals that met the urgent environment, political, and economic challenges facing our world. The SDG were set in 2015 by the United Nations General Assembly and are intended to be activated by the year 2030. They were adopted as a universal call to action to end poverty, protect the planet, and ensure that all people enjoy peace and prosperity by 2030. So this is the reason why it is people, planet, prosperity, peace, and partnership. The aim of sustainable development is to balance our economic, environmental, and social needs, allowing prosperity for now and future generation. So sustainability is the key to a better future. Why education? Education is the key that will allow many other sustainable development goals to be achieved. When people are able to get quality education, they can break from the cycle of poverty. Education, therefore, helps to reduce inequalities and to reach gender equality. Thus, education for sustainable development promotes the development of knowledge. So you can see knowledge, skills, understanding, and values and actions required to create a sustainable world which ensures environmental protection and conservation, promotes social equity, and encourages economic sustainability. Why children? Children are vital to the nation's present and its future. So watching your child furnish from an infant to an adult is certainly a great privilege, and what is instilled in them at an early age will be of great value to their future. In other words, children are the ones who are very vital for deciding how the world is going to be better after some year. So if one can do some good in the life of a child, then there can be change, at least a slightest change in the world to come. And if most of them think on same lines, then we can hope of a better future ahead. Also, children can build great knowledge from a young age with a window of opportunity to develop into anything they love. Now, why stories? So we'll all know that the learning to read is important. So research shows that people without goal literacy skill do worse in education and are more likely to be unemployed or even suffer from health and relationship problems. So most small children live their lives in quite limited environment. Reading story to children can show them far-flung places, extraordinary people, and eye-opening situations to expand and enrich their world. It can also be a great way to helping them deal with real-life situations that they need help to deal with. Moreover, it gets even more surprising when you look at the effect of reading fiction to children or their social behavior. So scientists have found that children who have fiction read to them regularly find it easier to understand other people. So the challenge to writing a book for the science, to writing book for the children in age 6 to 12, it is very difficult. So the writing for the child itself is much more difficult than writing for adults, and everyone agree with, I think it's agree with me. So given the stages of growth in childhood and the different level of awareness, and in the field of writing about sustainable development for children, it is more difficult than others. For some reason, firstly, the child's short attention, if the age is 5 plus 1, it's equal the duration of his attention in minutes, compared to the complexity and intertwining of sustainable development terms and their needs for long explanation. The second, the lack of motivation and elements that attack the child to simulate the application of the aspects of sustainable development, such as water footprint, global warming, plastic damages. So this is the part of the story that I written 6 stories. So the first story focus on, or before it, it includes 6 titles that aim to introduce key terms in the field of sustainable development, environment, natural circulation, natural change, water footprint, greenhouse gases, and finally sustainable development. For the second story, includes also 5 stories that offer the following: a clear model for a sustainable environment and introducing children to natural resources, elimination of gender discrimination by painting a picture of an environment in which there is no gender discrimination in the first place due to the equal participation of all in work and wages. Promote public health by respecting the natural order and narration what nature provides of a plant and animal product and using every fruit in its season. For the third books present 6 stories as well that include the following goal: encouraging the child, encouraging the child to take care and think about nature, creating an event such as Natural Day with the aim of creating a sustainable environment and society, and helping to purify the atmosphere by reducing pollutants. The fourth book provides a general awareness of waste and stimulate this child to think about its feet and be responsible, not a consumer. And in addition to teaching recycling, it also aims to separate equality and eradicate poverty through the donation wall, reducing waste by reducing consumption. The fifth book, I found that the 6 beasts to virtualize the most prominent dangers that threatening the earth and the human being in the form of most monsters that the child can see and understand how to eliminate them. So it's have the plastic monster, the hunger monster, the heat monster, the drug monster, the monster of clothes, and the last one, monster of manufacture. The last book, by this book, the children are exposed to the tragedy of animals and their natural environment in light of a human greed and indifference and interest of increasing profit and industrial well-being. In summary, the photo story are one of the essential tools that attract children, so they have been used in written stories to explain the Sustainable Development Goals to children. This series contains 6 stories or 6 parts with expressive illustration. Each story consists of 5 to 6 parts. The first story deals with the right and protection of animals. The second deals with the independence and production. The third deals with how to preserve the water environment. The fourth story deals with goal of hunger, poverty, and environment pollutants, while the fifth and sixth story talk about preserve the climate, environment, and recycle waste. The target age group is children between 6 to 12 years old. It was written in Arabic language. The writing period listed 6 months and was published in Al-Sadiq Publishing House with local and international deposit number. The stories won the Creativity Medal at the 3rd International Scientific Conference on Creativity and Innovation for the period 15 to 16 July 2020 at the University of Babylon. The stories were sent to the Ministry of Education with the hope that they would be taught as part of the health curriculum in Iraqi primary school. My last words here: our responsibility is to teach children how to preserve and improve all components of the environment to live in peace and well-being. Otherwise, we will be the generation that knows so much and has done little. As Allah said in Quran, Surah Al-Baqarah, verse 30, بسم الله الرحمن الرحيم وإذ قال ربك للملائكة إني جاعل في الأرض خليفة قالوا أتجعل فيها من يفسد فيها ويسفك الدماء ونحن نسبح بحمدك ونقدس لك قال إني أعلم ما لا تعلمون. صدق الله العظيم. We are the best creation of God. Let us preserve our big house. Thank you for your attention.
Thank you very much for your fine presentation. Indeed, this is a very interesting topic. I realize telling stories are very important in learning children ethics and good habits. Thank you again.
Thank you so much, Dr. Manar.
We will continue now with either Dr. Ahmed or Dr. Ayat. Please skip sharing screen. Dr. Ahmed?
Yes, Dr. Manar, I am here.
Let me present you Dr. Ahmed.
Okay, Doctor.
Dr. Ahmed obtained his MSc degree on plasma physics from University of the Hook on 2010. Then he has got his PhD in the field of nanotechnology and material science by split site program between University Saint Malaysia and University of Zaho. His lecture is entitled The Effect of Different Substrate Inclined Angles on the Characteristics Properties of Zinc Oxide Nanorods for UV Photodetectors Application. Dr. Ahmed, can you start your presentation and within 15 minutes, okay?
Okay, Doctor. My screen is shared or not, Dr. Amana?
Yes.
Thank you. Hello, everybody. Thank you for organizing this very important moment in a scientific with our border invitation conference. Especially, I would like to thank the Dr. Suhat and Dr. Belivan for giving me this opportunity. I am Dr. Ahmed Fattah.
What is the problem with your screen? Oh, it's
okay. It is okay, Dr. Amana? Dr. Amana?
Yes, it's okay now. It's okay now, okay.
Can I begin? Start?
I can see your screen clearly, okay?
Okay, thank you. It's okay, Dr. Amana, can you see my screen?
Yes, I can see your screen.
Okay.
Okay, you can start, okay?
Okay, thank you very much. I am Dr. Ahmed Fattah from University of Zaho. I have PhD in nanotechnology and material science. Recently, I have many publications in the top journal in the field of the nanotechnology. My seminar it's about the effect of a different substrate inclined angle on the characteristic properties of zinc oxide nanorods for UV photodetector application. This research recently published in the Journal of Material Science, Material and Electronics. It's the best one, I think it's the best of the one journal in this field. The aim of the study, first, the effect of a different substrate inclined angle in a wide range of the angle from 0 to 90 degrees with a vision on the growth and surface morphology, size, length, shape, structure, and crystal size, and optical properties of zinc oxide nanorod. Also, high-performance UV photodetector-based zinc oxide nanorod were fabricated for the optimum substrate inclined angle at 70 degrees with a visual using different bias voltage. Why I chose the zinc oxide? Because zinc oxide is a very important, very important type and technological significant semiconductor material due to its unique properties such as direct band gap, transparency in the visible range, absence of toxicity, high electrochemical stability, a wide exciton binding energy, abundance in nature, resistivity control over range 10 to minus 3 to 10 5 ohm centimeter, excellent optical and electrical properties, a high mechanical, chemical, and thermal stability. These properties make the zinc oxide is available for many non-electronic devices such as UV light sensor, gas sensor, dye sensor, solar cell, light emitting diode, transparent conducting layer, a photocatalyst, thin film transistor, pH sensor, and Schottky diode, and another application. Also, the zinc oxide can be prepared with a different nanostructure, such as nanoflower, nanoroll, nanotube, nanowire, nanoring, nanofiber. Most of this nanostructure I have prepared for a different parameter. The nanorod and nanowire nanotube display 4 excellent properties which are not investigated on its bulk nature, such as quantum effect, high surface area to volume ratio, unique optical properties, and unique electrical properties. These unique zinc oxide nanostructure properties range for a large area of application of a zinc oxide nanomaterial. The zinc oxide nanostructure can be prepared by the different chemical and the physical techniques such as chemical mass deposition, hydrothermal, RF scattering, electrodeposition, spray pyrolysis, metal organic, chemical, and vapor phase transparent and pulse laser deposition, molecular beam epitaxy, thermal evaporation, and another technique. In this research, I focus on the chemical bath deposition method because it is one of the method most effective, efficient, high performance, because it is have own advantage such as low cost, low temperature, environmental friendliness, not require complex instrument, simplicity, non-hazard, and can be deposited of a semiconductor thin film on any substrate, such as flexible or not flexible. Also, the nanostructure can be controlled by a different main parameters that have directly affected on the properties of the nanostructure, such as precursor concentration, growth time, bath temperature, pH of a growth solution, substrate angle, thickness of the seed layer, and types of a substrate, and another parameter. In this, all these parameter I have worked on it, and I published for each parameter in a high journal, high impact factor journal. This research just focus in the effect of a substrate angle. The inclined angle is defined the angle between the horizontal layer, vessel or apical, of the growth solution and substrate. There are very few researchers who deal with this subject because the researcher just focus on one angle. It's 90. To my knowledge, it is the first time to study the wide range of the substrate inclined angle, which is 6 different substrate angle from 0 to 90 degree. The experimental setup of this research is first preparation and cleaning the glass substrate, deposition of a seed layer on the glass substrate by RF scattering by using the high purity zinc oxide target, annealing the zinc oxide seed layer over the glass substrate at 400 degrees for 2 hours. Fabrication of a zinc oxide nano on a glass substrate using the modified CVD method, morphological characterization of the fabricated zinc oxide nanorod, UV photo detector device fabrication and preparation and deposition of a metal contact on the top of the zinc oxide nanorod by RF scattering, annealing the UV sensor and photo detector, and the electrical characterization of the UV photo detector. The growth process of the zinc oxide nanorod, first the zinc nitride hexahydride is dissolved in the deionized water under the magnetic stirrer to get the homogeneous solution, and separately hexamagnetic tetraamine is dissolved under the magnetic stirrer to get the homogeneous. After that, the two solutions are mixed together under the magnetic stirrer to get the homogeneous growth solution. After that, we convert this growth solution into the vessel or a vic or the beaker, and I prepare the six different sample. Each sample or substrate I put it in a beaker in a different angle, inclined angle. This is the inclined angle from the 0, 40, 50, 70, 82, and 90. After that, I convert this beaker containing the zinc oxide seed layer over the glass substrate to the oven for 4 hours at 98 Celsius degrees. After the finishing, the required growth required time for the growing or for a CBD, the fabrication of fabricated zinc oxide nanorod were taken out of the deposition solution and were ionized with the deionized water, and to remove the remaining zinc salt and dry by a nitrogen gas. It is to dry it. After that, after the successful zinc oxide nanorod on a glass substrate by CBD take at a different substrate inclined angle, we studied the all characteristic of the such as morphology, XRD, and we get the optimum substrate inclined angle, which is 70 degree. I made the UV photo detector for the optimum substrate inclined angle with the high aspect ratio and the high growth rating. The UV photo detector, this figure shows the structure and the electrical system for the electrical IV characteristic measurement for UV photo detector. This for glass substrate, seed layer, and after that zinc oxide nanorod, and I deposited the aluminum contact by using the aluminum grade target by using the high purity of the aluminum on the top of the zinc oxide nanorod for the optimum substrate inclined angle. After that, I use the Kesley to measuring the passing or the IV characteristic of the UV photo detector. The result, this figure showed the top view and the cross section or side view FESM morphology of the different substrate inclined angle. A for 0, B for 40, C for 50, and D for 70, E for 80, and figure F for 90. From all this figure, we can conclude that the substrate inclined angle have the remarkable effect on the surface morphology, such as size, shape, diameter, density, distribution, and hexagon and alignment and hexagonal of the zinc oxide nanorod. We can also conclude that the zinc oxide nanorod are gradually improved as the substrate inclined angle are increased from the 0 to 90. Also, we can conclude that from the figure the optimum substrate inclined angle is the 70. You can see from the figure we have the uniform size, shape, alignment, and high aspect ratio and high growth rate. Also, the most of the zinc oxide nanorod have the same shape and the same size and same and completely hexagonal shape of the zinc oxide nanorod. Also, this figure shows the the XRD result are investigated of the different, we can see the effect of the different substrate incline angle, the intensity of the XRD pattern along the 0, 2, which is preferred to the C-axis, which is confirmed the zinc oxide nanoroad. It is preferred or oriented well aligned over the whole substrate incline angle for when increasing the substrate or changing the substrate incline angle. Also, the XRD confirm that the substrate incline angle can be has the remarkable or a significant effect on the for example, the crystal size, the intensity, and the volume, and the bond length, and the dislocation density. All these parameters change with the change in the substrate incline angle. Also, the substrate inclined angle effect change the lattice parameter of our zinc oxide nanorod and the stress and straight, and also we have the tensile and the compressive in such sample compressive stress. Also, the optical properties of zinc oxide nanorods for a different inclined angle can are measured or have been studied by the optical transmittance spectroscopy. Also, we can see from this figure the substrate inclined angle change the optical properties of the zinc oxide nanorod. Also, the energy band gap is ranged from the 3.2 to 3.16. This results show the IV characteristic of the UV photodetector. The UV photodetector, the IV characteristic of the photodetector of aluminum zinc oxide nanorod under the dark and the illumination 390 nanometer with the power of 55 milliwatt of a centimeter square in the range of the bias voltage from the -5 to 5. It is shown the ohmic behavior. You can see from this figure we have the ohmic behavior. It is dependent on the work function of the semiconductor and we used the aluminum, and as we know, the work function of the aluminum is higher than its N type, higher than the zinc oxide, and we get the ohmic contact. Also, this figure shows the responsibility, spectral responsibility of the fabricated UV photodetector as a function of the incident light source wavelength as a fixed 5 voltage bias voltage under 39 nanometer wavelength of the UV light. This figure shows the repeatability or stability of our UV photodetector sensor properties on and off of the fabricated aluminum UV photodetector based on zinc oxide nanorod ground for the optimum substrate inclined angle, which is the 70 degree, and the pulse UV light 390 nanometer at base voltage from 135 bias voltage. The UV photodetector device based on the zinc oxide nanorod has the lower dark current, which is about 6.3 microampere, and the high illumination current, which is about the 341 microampere. The obtained high photocurrent of the UV photodetector device is referred to the high quality crystalline and the high surface area to volume, or related also the high aspect ratio of our sample as the at the substrate inclined angle, which is the 70 degree. Also, the different bias voltage, it was noted that the fabricated, from this figure, we can conclude the fabricated UV photodetector have excellent stability and repeatability behavior. The result clearly showed that all curves displayed the acceptable difference with the time, and the photocurrent value for every case on or off cycle are steady and repeatable. The rectangular profile are except or are shown for all curve. In all cases, the photocurrent of UV photodetector is rapidly increased to saturation upon the exposure UV light 319 nanometer wavelength, and then exponentially decreased. We can see decrease again under the dark condition, which is about 6.3 micro ampere. Also, another important parameter when we can see our sensor, it is a good or not, which is the rise time and a fall time of a fabricated UV photodetector. The response or this on or our UV photodetector or sensor show the rapid rise or response time. Also, as a bias, which is about
Dr. Ahmed, 5 minutes left. Okay.
Okay, which is about the 3 seconds, and the fall time, which is about 2 seconds. Also, this table show the comparison between the my result presented in this work and the and compared with the result reported in a literature such as responsivity, response time, recover time, sensitivity, and again the first one 135 base voltage. This is for my UV photodetector. We can see for 5 base voltage we have the high responsivity. You can and we compare with the literature recent work in this field. Just one it is higher for my result, and another not. But we can see the response time. It is very rapid, and recovery also, and the sensitivity it is higher. Most higher, it's about 5,000. And again for and again for this UV photodetector is about 54 percentage. In the last conclusion, in this work, vertically wall aligned zinc oxide nanorods were successfully fabricated using the low-cost CBD at a different substrate inclined angle with the visual for UV photodetector application. The study of a different substrate inclined angle with the visual shown that the variation of the substrate inclined angle have a remarkable and significant effect on the morphological structure and optical properties of a zinc oxide nanorod. Also, the morphological structure optical measurement depends that the 70-degree substrate inclined angle, it is the optimum angle for the UV photodetector for high quality because it shows a high aspect ratio. And another also the results show the variation of the substrate inclined angle resulted in the variation of a diameter and average length between in the range from the 58 to 249 nanometer, and average length in the range of the 300 to 2004 nanometer respectively. And the higher growth rate, higher average length, and higher aspect ratio were investigated for the zinc oxide nanorod fabricated at 70 degree, which is the optimum substrate inclined angle. Also, the preferred orientation of the zinc oxide nanorod was found to be along 002 peak, diffraction peak was a hexagonal vorticized plane, and the XRD peak intensity was increased with increased the substrate incline angle. The average crystalline size, which is in the range 460 to 58 nanometer, increasing in the substrate incline angle, resulted in the reduction of the average zinc oxide nanorow transmitter from the 44 to 3.3%. The optical study indicated that zinc oxide have the direct energy band gap also in the last, and the different biovoltage studies show that the UV photodetector bit on the zinc oxide nanorow has a higher stability and the repeatability at the 5 voltage bias voltage. Last one, the photodetector device sensor exhibit or show the responsivity or value of the 3.49 ampere per watt to 390 nanometer light wavelength at 5 degrees. Thank you for your attention, and sorry for my voice not clear because I am very sick. Thank you, Dr. Amana, again.
I'd like to thank you deeply for your fine presentation. Indeed, it is an excellent work with plenty data, and there are many questions after at the end of this session. Okay.
Yes, thank you.
Really interesting.
Thank you so much.
Okay, is Dr. Ayat? Does Dr. Ayat attend our session or not yet? Dr. Ayat? Okay, can we start discussion with the participants? Dr. Dina, do you hear me?
Yes, I hear you.
Okay, can I ask you some questions about your work?
Sure, sure.
Okay, your work really was excellent. Really, it was excellent work. Indeed, it was not single work. There are different materials. You use different materials, and you investigated different materials. So, my question: did you study the components of these materials to each other, or each material is single material?
Did you mean synthesis or characterization?
Synthesis. In the synthesis protocols. Okay?
Yes.
You
yes,
use single material or combined materials with different ratios?
We synthesize different material by condensation reaction, or condensation reaction, or drugs modification also, or a complexation. And after that, after the synthesis step, we characterize by different technique, such as IR, NMR, HNMR, carbon 13, also XRD, another technique also specific with the application, such as gas storage, or يعني ممكن BET. BET it deals with surface area, or
yes.
BH deals with pore size or pore volume, and H-Zorb analyzer, which deals with gas storage capacity.
Okay, this is for characterization. I mean, when you prepare these materials, did you use different components or different ratios of each component, or single component in each research article?
Different components.
Different components, okay.
Yes.
Do you know what are MOFs? Do you hear about MOFs?
Yes. Metal organic framework.
Yes, yes, okay.
Yes.
What are the comparison between your materials, okay, and the MOFs the efficiency. What is the difference between your materials and the MOFs?
I think it's the same because it's metal. We use metal or different metals such as Zn, Cu, tin complexes, and these complexes we use as gas storage. So MOF, it's the same. Also, we work with the MOFs.
Okay. Does any of attendees want to ask Dr. Dina or discuss with Dr. Dina any matter with her researches? Dr. Said, do you want to ask or to investigate any matters with Dr. Dina?
No, thank you very much, Doctor.
Okay.
Thank you.
Thank you very much, Dr. Dina. Thank you very much.
Thank you, Dr. Manar. Thank you. Thank you.
Okay, Dr. Huda. Is Dr. Huda present or she left? Okay, Dr. Suhaid, do you want to ask any questions for the presenters?
Thank you, Dr. Manar. Yes, I hope Dr. Huda can make contact with Dr. Rana Dijani or Dr. Ulal Aliya, عفوا, because you and they have the same goals. يعني دكتورة هدى with دكتورة Rana, maybe we could make a good contact.
Yes, okay, but I don't know if Dr. Huda is still with us or she left.
Yeah, I don't know also. Okay.
Okay, welcome, Dr. Amal. Do you want to ask Dr. Dina for her interesting article? Dr. Amal. Okay, thank you all for attending this session. And I see there are no questions. Dr. Berivan, do you have any questions for Dr. Dina or Dr. Ahmed?
I'm ready for any question.
Thank you, Dr. Ahmed, for your wonderful work.
Thank you, Dr.
Okay, thank you all, and good luck for you. And it's okay. I think the session, no more questions, and it's okay.
Thank you, Dr.
Okay, thank you.
Thank you. Thank you.
Thank you.
Thank you. Thank you all, and I'm really happy to be with you in this session.
Thank you, Dr. Manar.
Okay, goodbye.
Goodbye.
Very much, Doctor.
I wonder if any one of the attendees want to ask me about AFM.
I'm wondering why the panelists are not there.
No one is there?
I think it's you, the only from the presenters, let's say, or the panelists are there.
Okay. Thank you.